Good morning, one and all. Today we will going to discuss the circular array antenna. I hope that in my previous video we learn about the planar array type of the antenna. Similar case, we learn about the next type of the antenna, which is called as the circular array type of the antenna. Here is the schematic representation. Means here instead of the n isotropy point sources along the x and y axis and which is joined together by the equidistance dx and dy, the same case your circular array type of the antenna which is placed along all axes. From this schematic representation we shows that in along the all axis, rather than we called it is all planes, starting from here n 1 2 3 n minus 1 n minus 2. In this way we are able to measure it, and from this point we consider the electric field. We are able to find out the electric field at the distance point. Then here the angle which is to be measured from this point n isotropic point sources, which is the psi n, and from that point we have able to measure the distance r. At a distance point we measure the electric field at a point distance, which is called as the point electric field. From here the array factor, the normalized field, can be written. Your all the circular array means here the circular array type of the antenna. Array means here more than the two isotropic point sources up to the n number of the isotropic point sources which is located along the axis or along the plane. Here in case of the circular array type of the antenna, all the points which is located on the plane, not for the axis. And here basically the antenna which is placed along the spherical coordinate system, and in case of the spherical coordinate system its component is r, theta and phi. Hence we have to be normalized field can be written as E of r, theta and phi, which is equal to summation of n, which is equal to a 1 to n a of n into e raised to minus a r rn upon rn, where rn is the normalized resistance value should be given. Its value is r square plus a square minus 2ar cos psi n. For this case, from this equation where r is very greater than as compared to the a, that's why this equation is reduced to here. Basically this equation is reduced to where r is greater, very greater than a. Hence rn which is equal to, there is r square minus 2a r cos phi. That's why r is very greater, that's why 2a is less. That's why this equation is r square minus 2ar cos phi, and which is to be reduces to the approximately equal to r minus a cos psi n, which is equal to ra. This will be reduced to in the rectangular coordinate system. From that rectangular coordinate system we have to find out the finally the value of the r of n, and the amplitude term should be given. For this case 1 upon rn is approximately equal to 1 upon r for all n type of the values. And from this equation 18.31 and 18.32 are valued for far zone array. Hence this will be reduced to e of r theta phi e raised to minus j kr upon r. Means basically the near field region and far field region we have calculated the electric field. So a of n is the excitation coefficient, and this excitation coefficient is represented in the amplitude and the phase term. Then psi of n, which is equal to 2 pi n into n in the rectangular position of the n element. And in general equation we have to find out the excitation coefficient. Generally the excitation coefficient can be represented by a, which is equal to I of n e raised to j alpha n, where I of n is the amplitude term and alpha n is the phase of the excitation of the nth element relative to the choice array element of the zero phase. That's why this equation is represented by e of r theta phi, which is equal to e raised to j kr upon r into summation of n, which is equal to 1 to n I of n e raised to j of that value, and array factor is represented to the here. Now from that equation there is an expression 18.36 can be represented the array factor of the circular array of the n equispaced element, because there is not any loop, or it will be equidistance. Basically there is equidistance along the x and y axis in case of the planar array, but here along the planes. That's why the array maximum of the array factor occurs when all the phase terms in with respect to the equation number 18.36. And from that equation, this term, the exponential term inside the square bracket, that is the k sine theta cos phi, phi minus phi n into alpha n, this, then this will be considered as the k sine theta cos phi minus phi n plus alpha n, which is equal to 2m phi, and m which is equal to 0 plus minus 1 plus minus 2 for the all the n values, and the principal maximum m which is equal to 0, then it will be defined by the direction of that theta and phi component, which is to be given alpha n which is equal to minus k sine theta cos sine theta cos theta 0 and phi 0. From that equation here, n which is equal to 1 to up to the n, if the circular array is required to have a maximum radiation in the direction of the theta 0 and phi 0, then the phase of its excitation will have fulfilled in the equation number 18.38. Then the array factor of such array, it will be represented by here, that is array factor of theta phi component should be given, n which is equal to 1 to n I of n e raised to j k cos psi n minus cos psi o of n. Then what is the psi of n? Psi of n, it will be represented is the angle between the r dash and a dash of p of n, and psi 0 of n, which will be represented the angle between of this pointing in the direction of the maximum radiation. Then finally we have to be find out the uniform circular array 3-dimensional pattern. See, here is the, in case of the previous, the linear planar array, there is only one radiation, maximum radiation occurred along the y-axis, and all the minor lobes will be occurred along the, in between the planes. But in case of the uniform circular array, basically the maximum radiation will be occurred along the y-axis, but there is a n number of the radiation, the major lobes will be occurred throughout the middle major lobes. This is the basic difference between the circular array and planar array. My dear student, I will take that all the points from Antenna Fundamental by Balni's book. This is very fantastic and good book. You also refer that books for the more information, more relative information of this presentation regarding the planar array and the circular array type of the antenna. Thanks for watching my video. Please subscribe my channel. If any query, you write my on comment page, and if for more information about the antenna and its fundamental, then you please contact me of the given email ID. Thank you very much. Have a nice day.